Hello everyone, and welcome to the second episode of Coherent Coder. In the previous episode, we looked at introduction to C programming. So now in this episode, let's look at data types in C programming. So let's roll that intro. Before we go and look at what data types are, let's first understand what variables are. Variables are memory locations in which we store some data. The type of data that you store in it totally depends on you. Now let's look at the syntax of variables. You can think of syntax as a template to writing a certain piece of code. Here we are going to look at the template of declaring variable in C language. To declare a variable in C language, we have to first write what kind of data we are going to store in it. We use data type to define that. Next, we have the variable name. Variable name is a unique name decided by us to differentiate multiple variables from each other. Next, we have the equal to symbol and the value after that. The equal to value part is used to assign some value to the variable which we can access using the variable name. Now let's understand variables better with the help of an example. You can think of variables as your bank account, right? So what do you do with your bank account? You go and deposit some money, right? You go and store some money basically. So that money will be there with the bank unless you withdraw it, right? In a similar way, you can store some data in variables, and this value will be there unless and until you perform some operation with the variable or the program ends. Okay, and you can think of the variable name as your bank account number. So if you know your bank account number will always be a unique value, right? So in a similar way, your variable name will always be a unique value. And how your bank can access all your details just by knowing your bank account number. In a similar way, you can access the value of the variable using the variable name here. So now that we understand what variables are, let's move on and look at data types hierarchy. Data types are basically data format specifiers, and these are used to know what type of data is stored in a variable, what kinds of operation can be performed, and how much memory that variable will consume. Data types are classified into three groups. First, we have primitive, then we have user defined, and we have derived. So now let's look at what each of these different data types are. Primitive data types. Primitive data types are data types which are built into C language and are considered as basic building blocks for coding in C. Let's look at what data types come under this category. First, we have int. Int here stands for integer. In this data type, you can store negative and positive numbers. For example, you can store minus 2000 and you can also store 5000. Int consumes either 2 or 4 bytes of memory. So this is dependent on your compiler and your operating system. And depending on this, the range will also change for it. So if it's just 2 bytes of memory, then it will be minus 32,000 to plus 32,000, and if it's 4 bytes of memory, then it will be the higher range. And the format specifier for int is percentile d. So you guys do not have to worry about the range part because this is just for your knowledge purpose. This you do not have to learn or remember. And about format specifier, we will get to understand what this is when we get to the programming section. Next, we have float. Float stands for floating point. In this data type, you can store numbers that have decimal points. For example, you can store 1.25 or 2.345, etc. Float consumes 4 bytes of memory and its format specifier is %f. Next, we have double. You can think of double as an extended version of float. You can store the same type of data as float but with an extended range. Double consumes 8 bytes of memory and its format specifier is %lf. Next, we have char. Char stands for character. It means that you can store one letter using char data type. For example, we have 26 characters in English, A, B, C, D, etc. So you can store one of these characters in char data type. You cannot store multiple characters using char data type. Char uses 1 byte of memory and its range is from -128 to +127 and its format specifier is %lc. So you might be confused thinking why the range for a character is from -128 to 127 instead of being from A to Z. That is because in C language, whenever we store a character, it is not stored as the character itself. For example, if you assign a value of A to a character variable, then it will be stored as a number format. And this number format is called as ASCII number. We will get to know about it later when we actually get deeper into the coding part. Now, let's look at some more primitive data types. Next, we have shortend. Shortend, you can think of it as a subset of int. So it can store the same kind of data as integer, but it can only store a limited amount of data when compared to int. Shortend consumes 2 bytes of memory and its format specifier is %hd. Next, we have unsigned shortend. So unsigned shortend is basically a shortend in which we do not have any negative numbers at all. And since we are removing all the negative numbers, the positive side of the range almost doubles. And its format specifier is %hu. Next, we have long int. You can think of long int as an extended version of int. Long int consumes 4 bytes of memory and its format specifier is %ld. Next, we have unsigned int. Unsigned int consumes 4 bytes of memory and it is same as what unsigned shortend was. So unsigned int is the same as int but with all the negative side of the numbers removed. So since it only has the positive side of numbers, its range is almost doubled. Its format specifier is %u. Next we have long double. Long double is an extension of double. Okay. So it can store a lot more amount of data. Long double consumes 16 bytes of memory and its format specifier is percentile, capital L and small f. Now that we have completed all the primitive data types, let's move on and look at examples of variables and data types. So I will show you how to code and declare variables and use data types and print some output on the screen. So we are going to exit the presentation and we are going to search for dev C++. Okay, now that dev C++ is open, we are going to go to the top left and then click on file and then click on new and then click on source file instead of a project. So now a new source file has been created. So now if you remember the structure of C programming, you will know that first we have the documentation section, and next we have the header file or the preprocessor directory section. Okay, so for our scenario, we are going to include the stdio.h header file. This header file provides us a function called printf, which we require. Next, I'm going to declare the void main function. So I'm going to say void main, bracket open, flower bracket open, and then click on enter. Okay, now let's get this bracket also to the new line for better understanding. Okay, so now that it's done, we are going to start declaring declaration of variables. Okay, so now if you remember the syntax of variables, first we have to define the data type, next you have to give it a variable name, then you have to provide the value of the variable. So let's start by declaring an integer variable. Okay, so I'm going to write int, which is the name of the data type, then I'm going to give a space, and then I'm going to write the variable name. So here I'm going to select I as my variable name. Then I'm going to give space, then equal to, then space, and then I'm going to write 2000 as the value of the variable. Now I'm going to use semicolon at the end. So remember that inside void main, you have to write semicolon at the end of each line to indicate that the line has ended. Otherwise, you will get compiler errors. Okay, so next, so this is the declaration of int variable, and this is how we declare variables in general. First we define the data type, next we give it a variable name, then we give it a value. Okay, now that we have seen the int declaration, let's move on and look at declaration of float variable. So I've written float, which is the name of the data type, then I'm going to give space, then I'm going to give f as the variable name, then I'm going to give space again, then equal to, then space, then I'm going to give the value. So here I'm going to select 25.e265 as my value. So this is the declaration of float variable. Okay, so now that we have declared float, let's move on to double. So I have written double now, which is the name of the data type. Then I'm going to use space, and I'm going to use d as my variable name. Then I'm going to give space again, then equal to, then space, and now I'm going to give the value. So I'm going to give 1033.37778. So this is declaration of double variable. Okay, so now we have declared double. So next we move on to char. So I've written char, which is the name of the data type. I'm going to give space. I'm going to use c as my variable name. Then I'm going to give space again, then equal to, then I'm going to say assign it a character. So I'm going to assign a here. Then I'm going to give semicolon, and this is going to be our declaration of char variable. Okay, so Now that we have written this program, let's save it. So you can see the save icon here. So we are going to click it. So now we are going to give it a name. So I'm going to choose variable underscore examples. Okay, then under save as types, I'm going to select C source files, and then I'm going to click on save. Okay, then I'm going to give enter here. Okay, so now before we move on to displaying these values on the screen, let's try and compile this. Okay, so I'm going to go to execute here. I'm going to click on execute, and I'm going to click on compile. So you can see that we are getting an error here on this line. So let's see what the error is. So it is saying A undeclared. So what it means is that it is trying to look for a variable with the name A, capital A, but it's not able to find any variable with that name. And that is why this is failing. Okay, so you have to always understand that when you are trying to assign a particular character to a character variable, you have to always give it inside single quotes. If you give it in this way, then it will understand that it is a character and you should not be looking for a variable. Okay, if you are not giving this, then you will get this error when you try to execute it. Okay, so I hope you understand why we have to put single quotes when we are assigning value to a character variable. Okay, so now that this is done, let's look at printing of variable values on screen. Okay, so now let's print all the values. So if you remember at the start we included stdio.h and I told you that we require it for a printf method, printf function. So here we are going to use that function. So we are going to say printf, we are going to open a bracket, then I'm going to use double quotes. Okay, so now I'm going to say percentile d. So first we are going to print integer variable. Okay, so if you remember, I told you that each data type is associated with a format specifier, right? So that format specifier we are going to use it here to display values on the screen. Okay, so the format specifier for int is percentile d. So I've written percentile d in double quotes. Then after this, I'm going to put a comma, then I'm going to give a space, then I'm going to write the variable name of int, that is I. Okay, so now after this, I'm going to put a semicolon. So this is how we print value of int variable. Okay, now next we are going to go and try to print value of float variable. So if you remember, the format specifier of float is percentile f. Okay, then after the double quotes we are going to put a comma, then give a space, and then we are going to write the variable name of the float variable, that is f. Then I'm going to come outside the brackets and put semicolon at the end. Okay, then give a space. So this is how we can print value of float variable. Okay, similarly we are now going to write it for double. So for double we have lf as the format specifier. So we are going to write LF percentile LF, and then we are going to put comma outside double quotes. Then we are going to give the variable name of double, that is D. Then I'm going to come outside the brackets and put semicolon here. So same thing, print value of double. Okay, so now next I'm going to print the character variable. So if you remember, the format specifier of char is percentile C. Okay, so now outside the double quotes I'm going to put a comma, then I'm going to give a space, and then I'm going to write the variable name of character, that is C. And then I'm going to come outside the brackets and put semicolon here. So this is how we print value of char variable. Okay, so now that we have written all this code, let's try to compile it. So now you see that we have 0 warnings and 0 errors. That is because we have put single quotes around A now. Okay, now next we are going to click on execute and then click on run. So you can see that there is some big and random value which you cannot understand, right? That is because all of these values are getting clubbed. So if you see here, this part is the integer value 2000. Okay, then this part is the value of float 25.3265. Okay, and then this part is the value of double, that is 1033.37778. Okay, and the last A is the value of the character, but we are seeing it all in a single line, right? This is not good looking at all, and we cannot understand it properly on first look. So let's improve this a bit. Let's close this. Okay, so now we are going to add something. So we are going to add /n for every printf statement after the format specifier. So this is \n. Okay, so now what we are going to do is we are going to compile again. We see that there are no errors and no warnings, so we are going to go to execute again and click on run. Now you see that everything comes under a different line, right? So you might be wondering how this happened. This happened because of /n. So /n denotes a new line. Okay, so whenever we give /n in printf statements, so whatever comes after it will be in a new line. So because of this, whatever came after the int value, everything was in a different line. Okay, and then whatever came after float, we are putting it in a new line. Then whatever came after double, we are putting it in a new line, like that. And that is how we got this result. Okay, so now let's improve this further. Okay, now we know that we can output these values, but we do not know what these values are, right? We do not know which of these values is int. I mean, we know it technically, but if you're showing it to someone else, then they do not know it, right? So, to improve that, what we are going to do is we are going to write some text here. So, we are going to write the value of int variable is, and in a similar way now we are going to copy this, to paste it here, and then paste it here, and we are going to paste it here. Now we are going to change the types here. So this is float, this is double, and this is char. Okay, so now that we have written this, let's compile again. We see 0 errors and 0 warnings. Then we go to execute and then we run again. So now we see that it shows whatever we have written before the format specifier, and then instead of the format specifier it shows us the value of the variable. So basically in printf what happens is, whenever we give format specifier, so this format specifier is replaced with the value of the variable. Okay, so this is how coding works in C. So now you can see that this looks beautiful, right? This is a very understandable statement now. You can see that the value of int variable is 2000. The value of float variable is 25.3265. The value of double variable is 1033.37778, and the value of char variable is a. Right? Simple. So I hope you were able to understand it. So now that we have completed the demo for variables, let's move on with the video. Now let's look at the second classification of data type, that is derived data type. These are types that have been derived from primitive data types. You can think of these types as an extension of primitive data type. Under derived we have array, we have function, and we have pointers. We will learn more about these things in the future videos. User defined data types. It is mainly used to assign names to integral constants. So for example, think of a scenario in which you do not want to write the number in a number format. For example, instead of writing 1 in a numerical format, you want to write it as ONE1, right? So these kinds of scenarios can be achieved with the help of user defined data types. So under user defined, we have structure, we have union, and we have enum. We will learn more about this data type in the future videos. So thank you everyone for watching my video. I hope you were able to understand what I taught you easily. If you have any questions, you can post in the comments, and if you have any suggestions, you can also post that in the comments. Please like and subscribe if you like my videos, and happy coding.